Hello guys, so we're gonna be reporting about the PCT or the proximal convoluted tubule. So what is proximal convoluted tubule? So proximal convoluted tubule guys is the convoluted portion of the vertebrate nephron that lies between the Bowman's capsule and loop of Henle. It functions specially in the resorption of sugar, sodium, and chloride ions and water from the glomerular filtrate. So I'm gonna show you guys a video about PCT or the proximal convoluted tubule, which I got from What Is, and it's gonna be just a short clip about it. Thank you guys. I'm Mary Grace Andales reporting. Bye bye. Proximal convoluted tubule cells are adapted for absorption in three ways. First is the numerous mitochondria. Second, there's a large surface area due to microvilli and basal channels. And thirdly, the blood capillaries are closed. Over 80% of the glomerular filtrate is reabsorbed here, including all the glucose and amino acids, vitamins, hormones, and about 80% of sodium chloride and water. Glucose, amino acids, and ions diffuse into the cells of the proximal convoluted tubules from the filtrate and actively transported out of the cells into the spaces between them and the basal channels. This is done by carrier proteins in the cell's surface membranes. Once in these spaces and channels, they enter the extremely permeable membrane blood capillaries by diffusion and carried away from the nephron. The constant removal of these substances from the proximal convoluted tubule cells creates a diffusion gradient between the filtrate in the proximal tubules and the cells down which further substances pass. Once inside the cells, they are actually transported into the spaces and channels, and the cycle continues. In an adult kidney, about 125 cubic filtrate enters the proximal convoluted tubule each minute. All but 45 centimeters cubed is reabsorbed.
Various solutes reabsorbed in the proximal tubule. The most relevant to diuretic action are sodium carbonate and sodium chloride. Until recently, of the currently available diuretics, only one group has acted predominantly in the PCT. Sodium bicarbonate reabsorption by the PCT is initiated by the action of Na+-H+ exchanger located in the luminal membrane of the proximal tubule epithelial cell. Bicarbonate reabsorption by the proximal tubule is dependent on carbonic anhydrase activity. This enzyme can be inhibited by the acetazolamide and other carbonic anhydrase inhibitors. More recently, inhibitors of the sodium glucose transporter isoform 2 have been approved to treat diabetes mellitus. The sodium glucose transporter is responsible for reabsorbing much of the glucose that is filtered by the glomerula.
Adenosine, which is released as a result of hypoxia and ATP consumption. It is a molecule with different receptor and complex effect of Na transplant in several segments of the nephron. Adenosine actually increases proximal reabsorption on Na positive via stimulation of NHE3 activity. Adenosine A1 receptor antagonists have recently been found to significantly blunt both proximal tubule NHE3 activity and collecting duct NaCl reabsorption, and to have potent vasomotor effect in the renal microvasculature. Because HCO3 and organic solute have been largely removed from the tubular fluid in the late proximal tubule, in the residual luminal fluid contains predominantly NaCl. Under the condition Na positive reabsorption continue, but the H positive secretion by the Na positive and H exchange can no longer bind the HCO3. Free H causes luminal pH to fall. The net parallel Na positive plus H exchange and Cl based exchange is NaCl reabsorption. Organic acid and secretion system are located in the middle third of the straight part of the proximal tubule, also known as S2 segment. This system secretes a variety of organic acid into the luminal pH side of the tubule, where most of them act. Organic-based secretory systems are also present in the early S1 and S2 segment of the proximal tubule.